All right, hi everyone. Sharing. If at any point I stop projecting while I'm presenting, start waving your hands so that I can speak up for you in the back. We are just checking out the people online here, and I think we're good to go. Okay, so I'm going to talk about Cyanobacteria 101, which, for many of you may be review of some basic cyano concepts. So cyano bloom basics, a little bit about cyanotoxins. I'm going to review the cyano program at DES and some new exciting things that we're implementing this year. And then a little bit on New Hampshire cyanobacteria trends over time. Okay, so let's start with the very basics. What are cyanobacteria? They are an incredibly diverse group of organisms, but they fall under the category of phytoplankton, which are also a very diverse group of organisms. But they are the primary producers in our lake ecosystems, so that they are the fundamental base of our ecosystems here. And there's so many different types. There's dinoflagellates, there's diatoms, chrysophytes, and green algae. So in a typical balanced ecosystem, all of these organisms have normal fluxes throughout the year, and they're typically more balanced with each other. They all require the same things to grow, so sunlight and warmer temperatures and nutrients in order to proliferate. But sometimes cyanobacteria, if there's an imbalance in either of these things or an imbalance in the ecosystem, cyanobacteria tend to be the ones to grow out of control. So we get what we call blooms, where they grow and grow and grow and grow. So why do we see cyanobacteria bloom and not other phytoplankton? We do sometimes see other phytoplankton bloom, but it's much less common. So for a little perspective, cyanobacteria has been on this planet for around 3.5 billion years. So they've had a mighty long time to perfect their strategies. So they have what we call a handful of competitive advantages that give them the edge over other phytoplankton. So one of those is a set of accessory pigments on their chlorophyll called phycobilins. So what these do is they allow the cyanobacteria to harvest a wider wavelength of light to perform photosynthesis. So that means they perform better in lower light conditions compared to other phytoplankton. So an advantage compared to other phytoplankton. Many cyanobacteria are also able to control their buoyancy, so they can move up and down in the water column to have greater access to nutrients in different parts of the lake, or rise up to the surface to have more access to sunlight for photosynthesis. So that's an advantage. And then some cyanobacteria have a set of specialized cells. So for some of these, they have heterocysts, which allow them to fix atmospheric nitrogen and make it usable for their growth. A lot of phytoplankton cannot do that, so that is very unique. And then some of them have resting cells called aconeids, which will overwinter in lake sediments. And then when the conditions become more favorable in the spring, they pop up and are ready to go right away. So clearly cyanobacteria are very good at what they do, which is why we typically see these bloom in our ecosystems when we have an imbalance. So we're mostly concerned about cyanobacteria when they are blooming. And this is a picture of a bunch of different blooms that have happened in New Hampshire to highlight the diversity of cyanobacteria. So they can look at a ton of different ways, from spilled paint to just cloudy water, streaks or ribbons on the surface of the water, clumps of strange material as well. And they can be all sorts of colors, from a deep green, blue-green, yellow, white, and black. So extremely dynamic appearance. They also can have different appearances or show up in different ways based on the time of day. So it's really common to see this material surface in calm mornings and then get distributed throughout the water during the day, only to then surface the next day. So it might look like they're gone, but they're just mixed into the water a little bit better during the day. It's also common for bloom material to move around a water body based on wind and wave action. So that's something to pay attention to. And then the duration of blooms is also highly variable. So some genuinely only last for a day and others can last for a full summer. So extremely variable in that way as well. So why are blooms bad? There's a couple, a whole range of reasons, but I'm going to focus on two of them. So ecological damage. What you're seeing is a picture of a fish kill. So when all of that bloom material dies off, the process of decomposition takes oxygen out of the lake environment and makes that water uninhabitable for other aquatic organisms. So you can get large fish kills like this after a big bloom event. Then, of course, we worry about cyanobacteria because they can produce a range of toxins, which can be harmful to humans and animals. And then when you have a bloom of these organisms, because there's an elevated amount of them, that amount of toxin can build up pretty quickly and really pose a threat to public health. So in addition to blooms being very dynamic in themselves, the toxicity of those blooms is another layer of dynamic on top of that. So the type of toxin that they are producing and the amount of each toxin can change rapidly over the course of a bloom. So it makes what we do really hard. So cyanobacteria blooms are increasing globally. And two of the major drivers of why we understand that that's happening are anthropogenic in nature. So the first is climate change. And we had some great talks earlier today that have talked about these things in a little bit more detail. But overall, our atmosphere temperatures are rising, which in New England means our lakes are staying thermally stratified for longer periods of the year. We are also seeing higher epilimnion temperatures, and cyanobacteria tend to do better in warmer temperatures compared to other phytoplankton, so that gives them an edge. We also have consequences of having a longer period for anoxia to build up at the bottom of lakes, which could mean you're getting phosphorus re-entering your lakes as well. As Sarah mentioned, we're also seeing shorter periods of ice cover on our lakes, which has consequences for how long we're seeing thermal stratification persist, and changes to some of the phytoplankton dynamics as well. And we also talked about this morning changes in precipitation. So instead of having more regular rain events over the summer, we tend to have longer periods of dry and then these huge rain events all at once. So this is changing how nutrients are flowing into our ecosystems from a more regular trickle to periods of nothing, and then these huge events of nutrients coming in. And because cyanobacteria are so good at what they do, they tend to be the first ones to take advantage of that and grow into blooms. So the second way in which humans are contributing to cyanobacteria blooms, is we've talked a lot about today with the last two programs, is excess nutrients. So this can come from anywhere in the watershed with stormwater runoff and that precipitation. So it can come from urban environments, agriculture and livestock, and then the residential areas are contributing as well from those impervious surfaces we just heard about. Your roadways, your septics, your beautiful lawns are all contributing as well. But great to hear some solutions that you can take personally to tighten up how much nutrients are flowing into your specific water bodies. Okay, so to switch gears a tiny bit and talk about cyanotoxins briefly, there are so many different cyanotoxins. This is a table of just a handful, but it is by no means an exhaustive list. And they vary in their mode of actions and what symptoms that they can produce in humans and wildlife. So to highlight some of the major categories, there are hepatotoxins or liver toxins, tumor promoters, neurotoxins, and those that have a toxic effect on multiple organs in the body. So some pretty heavy hitters here. Each of these toxins can exert both acute or chronic toxicity in humans, wildlife, and pets. And then, of course, smaller individuals, so children or our smaller dogs or people with compromised immune systems may have more intense reactions when exposed to these toxins. What does cyanotoxicity look like? It ranges and it does depend on which toxin you were potentially exposed to. So it can be fairly mild, from dermal irritations, eye and nose irritations, general malaise, fever. Gastrointestinal issues range from nausea, vomiting, diarrhea, gastroenteritis. Some of the neurotoxins, you can get tingling, numbness, and seizures. And then in very serious cases, you can have nervous system and organ failure, and in worse cases, death, which is much more common to see in dogs and animals because they're more likely to drink enough of the water to get exposed to a dose of toxin that would result in those serious consequences. So the EPA, Dave did mention, has developed some health recreational guidelines for two of these toxins, microcystins and cylindrospermopsin, and they also have more strict guidelines for drinking water, which are health advisory at this point. So this does exist as well to help manage exposure to these toxins. How are you primarily exposed to cyanotoxins? The primary route of exposure is through ingestion. So that could be through drinking water. There are some famous cases of contaminated drinking water in the United States. It could be unintentional ingestion via swimming. This does even happen with adults, but especially with children. and it can be in your food. So some of these cyanotoxins do bioaccumulate up the food web, but even if it's toxin that doesn't bioaccumulate, if that organism is living in an environment where that toxin exists, they will have some of it in their tissues. So fish, shellfish, there's emerging evidence that's suggesting that these toxins can be found on some of our crops from irrigation or actually integrated into the tissue of fruits and leaves. Some folks also take food supplements that are exclusively cyanobacteria. The FDA has started regulating this because there are variable amounts of toxins in these supplements as well. You can have dermal contact just from recreating in a water body with cyanobacteria in it. And then inhalation is a potential secondary route of exposure that's being researched right now. And you could be exposed just from recreation and breathing while you're recreating. Showering, some folks do pull in lake water into their house and use it for showering, and potentially living near a lake. My nightmare situation of exposure is an activity like water skiing on a water body with an active bloom, because you're creating these coarse aerosols and then are also probably ingesting a fair amount of it. Okay, so now that we've gone over some basics, I'm going to review our program and how it's currently functioning. We are implementing, as Dave mentioned, a lot of new aspects to our program this year that we're very excited about. So I'm denoting those with stars just so we can highlight where that's happening already. So this is also something Dave talked about in the opening talk this morning, is we're really hoping to urge people to always get used to doing what we're going to call a personal risk assessment. So cyanobacteria are dynamic, and there's one of me running this program and an intern in the summer, so we can't be everywhere all the time. But we're really lucky in that cyanobacteria is very visual. So you can actually take your risk assessment in your own hands, go to the lake surface, look to see if you see anything unusual, and make the decision for yourself and your families in that moment. Is it safe to recreate or not? Typically, you don't need a sample analyzed to make that call and make a good choice there. So what does doing this personal risk assessment look like? It's really just looking at the water for any discoloration or unusual growth. Throughout this presentation, you're seeing a lot of examples of what cyanobacteria looks like. So hopefully you can internalize some of that. And our advice is, when in doubt, just stay out and report it. So you can send me pictures of what you're seeing. I'll go over how to do that on the next slide. And we can get a sample reviewed so you can build your confidence in this personal risk assessment. And reporting it, you're also going to keep your community safe, because we can communicate about a potential risk for other people as well. So there are some organisms that people commonly confuse for cyanobacteria. So I'm just going to talk about two of them really quickly. So one is harmless green filamentous algae, which there's the two pictures of on the bottom there. So it tends to look more like billowy and tends to have bubbles caught in it, which is from photosynthesis. So what you can do to figure out if it is green filamentous algae is to literally put a stick in it. And if the goopy material comes down in strings off of the stick, then it's likely harmless green filamentous algae and not cyanobacteria. If it was cyanobacteria, it would coat the stick. So you wouldn't see any of that extra structure to it. So that's a really good tip to know about. Another commonly mistaken one is duckweed. When duckweed grows out of control, it looks like a bloom. I've had people send me pictures before and I'm like, oh my gosh, that's an aggressive bloom, only to see a picture of closer up and be like, no, we're actually okay. If you look closer, these do actually have tiny little leaves and little tiny root structures. So if it were cyanobacteria, you wouldn't see roots or leaves. It's much more a finer scale organism. So two things to watch out for when you're doing your personal risk assessment. But again, when in doubt, stay out, report it, and we'll figure out what's going on. So say you do your personal risk assessment, you do see something sketchy. What do you do? So we have this new bloom report form this year that I'm very excited about. This is going to help streamline how we communicate with you and how quickly we can get back to you when you are reporting blooms. So it starts out with a picture collage just to give you an idea of the diversity of cyanobacteria. If you have your smartphones, you can try and scan that and get it on your phone right now. If not, I'm sure Sarah can send these slides out to you. But basically, I'm just collecting a lot of information that I want about the situation in the water body. So information about the current bloom, images. So take a lot of photos of the bloom that you're seeing, and we have spots to upload it in this survey. And then some general information about the water body. Is there public access? Is it a drinking water supply? That sort of thing. I will always ask if you can take a sample, and if you are able to, I'll give you sampling instructions right in that survey form. If you are able to take a sample, and even better, if you're able to deliver it to DES, then I'll get results back sooner to you, because the chances are, if your water body's blooming, there are other water bodies blooming across the state. So you can help us out and get information to you sooner by bringing it to us. In the summer, I do have an intern who helps me get around the state, but it can take a little bit longer. And then just your information, so we know who to contact with results and how to communicate about this.
Is that online?
It is, yes. So if you can find it here, you can find it through the link. I'm going to share it a bunch of ways. But if you just type in NHDES HAB for harmful algal bloom, our website will show up, and it's right on our website already. So once you hit that submit button, you'll get this screen that says thank you for reporting, and it's a reminder to stay out of the water, and definitely keeping children and pets out of the water as well. And a little reminder about when we are and aren't available. Unfortunately, we're not open on the weekends, but you can rely on your personal risk assessments to make the right choices on the weekends. And we are open 8 to 4 Monday through Friday. So if you're reporting outside of that time, you'll hear from us as soon as we return. Okay, so once we get a sample, what are we doing with it at DES? Ultimately, we're all mostly interested in the toxin aspect of this. And we do take some subsamples for future toxin analysis. We use a technique called ELISAs, but we don't do that until the winter. And the reason we don't use toxin analysis for our health advisory issuance and removal is it's super expensive. It's very time intensive to run these tests, and the results would be too delayed to inform public health in a meaningful time scale. And there's a bunch of different cyanotoxins. So a lot of programs that run based off toxins are really only looking at microcystins, which is one toxin. So instead, we run our program based off of a cell count, which we hope captures the risk associated with more than just one toxin. So through studies, that 8 microgram per liter threshold from the EPA has been related to 70,000 cells per mil of cyanobacteria. So we do that by looking at the samples microscopically, and we identify what cyanobacteria is there, and then we enumerate to get to see if it's above or below that threshold. If it's below, we may issue an alert, and if it's above, we will definitely be issuing an advisory. This year, we are pairing the word advisory with the word warning. This is feedback from our Cyanobacteria Advisory Committee that suggested that advisory doesn't really have a big impact if you're not familiar with our program. But by pairing it with a word like warning, we're hoping to catch people's attention a little bit more and have it be more immediately impactful. Okay, so a little bit more about what an alert and advisory are. So an alert is really a step down from an advisory. It's saying we think there's a situation going on, pay attention. So when do we issue these? These are issued when cyanobacteria is below the advisory level, but we think it could develop into something it's like just below the advisory level. Sometimes we issue them if the bloom has passed by the time the sample is analyzed, but it could reappear because they are dynamic. We just want to let the community know to be on the lookout. And sometimes we will issue alerts if we, before we even look at a sample. So sometimes people report on a Friday afternoon and there's no way I can look at a sample before the weekend, but we want the community to be aware of the situation. So I would issue an alert to let the community know, pay attention, stay out of the water if you see it. We're going to look at a sample on Monday. Okay, thanks, Sarah. And let's see. So we resample if there's continued presence or changing conditions, and alerts are active for a week. Advisories are a more formal statement. They're a lake-wide warning that the water is currently unsuitable for wading and swimming. Don't come in contact with the bloom material. So these are always issued if the cyanobacteria density exceeds that 70,000 cells per mil. And then if we do issue an advisory, lakes are resampled weekly until the cyano concentrations drop below that 70,000 cells per mil. How do we communicate about these different things? Alerts and advisories, we start communicating the same way. So I will email what we call a water body specific email list, which is a group of emails that I'm working on collecting for each water body to let the community know what's going on. And we also post the information on our Healthy Swimming Mapper, which is new that we're putting alerts on there this year, but we're very excited about that. Advisories, we also work with town officials to post signs on waterfronts, and then NHDES social media also posts when we issue and remove advisories as well. This year, we're doing something different as well. It's going to be a weekly statewide cyanobacteria update, and that's shared in some really public ways that I have some links for here if you want to sign up for those. But that will just summarize where there are active advisories, where there are active alerts, and where advisories have been removed within that week. just so folks know for a broader glance across the state. We do have a wonderful new mapper that we'll be rolling out. It's not active quite yet, but we're very close. My wonderful coworker, Michelle Condon, created this. We're very excited about it. There's a bunch of features that I'm kind of just going to skim through. You can search for water bodies. It tells you when each summary was last updated. And if there were no current, so we have fecal bacteria sampling. Our beach sampling is on this map as well. So it's informing healthy swimming overall. And if there were no alerts or advisories, the little box would say that. Advisories and alerts show up as colored rectangles on the map. And it will be found at the same mapper link that you've always used. If you've come across this resource from us before, it's just gotten a facelift on our end. And again, it's new that alerts are going to be on here. So if you're interested in pursuing and understanding more about this, if you actually click on the advisory that you're interested in, the map will zoom you to that water body and open a dialog box. And we have a bunch of information on there. So it'll tell you it's an advisory. The whole water body will be colored red to say, warning, stay out. It'll tell you when we last sampled, when the advisory was issued, and then a whole bunch of new information that's never been on our map. So we'll have a verbal description of the bloom, what cyanobacteria was identified, the concentration of the cyanobacteria. If there had been a previous advisory within that year, those dates would be listed here. And historical advisories for all the years that we've been recording this information will be linked here as well. And then the fact that we have pictures on the map of the current bloom is new too. So we're leaning on the fact that this is very visual. So you can take advantage of that to communicate with your community. I have some more slides, but I'm worried I don't have enough time. Should I keep going?
I think we're going to wrap it up and Lisa.
Okay.
Because it's going to be out of here at 12:30, so you all will eat before you sign up for vote, right?
We can share these slides. So if you're interested, you can also email me and reach out. Sorry about that. My timing was thrown off. Yes.
Say there's an advisory that takes place at the beach or the boat ramp. Can you still swim off your boat in the middle of the pond or the lake?
Our official advice is that you shouldn't. Yeah, that's what we say because we can't be there all the time to determine the risk. And like I mentioned, that blue material can get moved around the water body in unpredictable ways. Some people choose to make a different choice than that if by doing their personal risk assessment. The risk is never going to be zero if there is an advisory for the water body at that time, but it is lower if you can't visually see anything. Yeah.
The bloom is visible, but the toxins are not visible.
Correct.
And the bacteria is always present now. And then when conditions are right, you get a bloom.
That's correct. Well summarized.
and when it's there now, can it be detected? The testing?
Yeah. Yep. Yeah. So you could do like Sarah will see it in her the normal plankton toes you may do through VLAP. You'll see it in the water column at much lower densities, but we do it that by microscopy too.
I can see the small lakes you would close it, but let's say you had an outbreak on a large lake like this, would you close the entire lake off or just a section? Or
I will specify that we don't close lakes. We post advisories.
Sorry, you're not telling anybody this stuff.
Yeah.
So you gotcha.
It is harder with bigger lakes. So far, Winnipesaukee has been the only lake that we haven't issued a whole water body wide advisory.
Right.
But it is challenging and we recognize that can be frustrating, but at this point, that's what we have the capacity to handle.
Reverse osmosis, can it be put?
It can remove some of the cells, not the toxins, if the toxins are free. Yeah.
All right, so we're going to just switch to Lisa right now. Again, Kate's available for questions.